Welcome to episode 7, and here we are. Here we are again in the API. My name's Blades, and yes, I did need a reminder on here that this is episode 7. That is how bad my memory is. That's a shame, isn't it? I'm getting old, and I need more coffee. So let's get on with this. I'm going to do this a bit weird, but I'm going to put in the result first. So it's going to be a layout, location, you know how this goes by now, equals 0, let's say, and we want out, we want a vec4, yes, the old vec4, I'm just going to call it color, because that's the only output we want. We want to output the colour of the fragment, and then it can go and get rasterized and other things done to it. And the computer will take care of that, so semicolon at. Now, we need all our ins from the static shader. That's that lot. Those are all copied. They have to be exactly matching. There we go. So if I go to there, Shift Alt, drag, delete, and put in, that's that lot done. Not hard. So they have to match, everything has to match. If anything here is out of place, that's it, the whole thing just falls over and falls to pieces. So that's that bit. Uniforms. We'll need a few, as usual. We need the obvious one, which is a sampler. And that's the 2D one I want. Don't just call it a sampler. Gosh, it'll give us the wrong thing. And that's a uniform texture. You've seen that before. In the basic shader version. There you go, uniform sampler 2D U texture. Yep, just using the same thing. Nothing different. Now we might do something different. Oh, lighting, yes. I remember what we're going to be talking about today. Lighting. Whoa, you're going to love this. Vec 3. We're going to put in our light colour. Now, light colour is misguiding. It is actually the colour, but it's also the brightness. The more colour it has, the brighter it will become. Interesting. So, think about that. It defines the colour and brightness. So if you want something to be red as an RGB value, you would put the red at 0.5 or 0.6 or 0.7 or 0.8. But the higher it goes, the brighter the colour. The RGB, the green and the blue, you would put to 0, and you will get a pure red thing, whatever you were drawing. So that's roughly how light colour is going to work. This one is a doozy. This confused the heck out of me, because what we're going to call it is shine damper. Yep, we're going to have a shine damper. Now what does that do? That's the spread of the reflectivity. Yeah. So how spread out and scattered the light becomes when it's reflected off a surface. That is usually in powers of 2, like 2, 4, 8, 16, 32. As soon as you get in quite high, like in above 16, I think we're really going metallic. So if you want something matte, put down 2. 2 is a good number. I think we start ours on 1, so it's definitely matte. Let's just have a look at our texture. Where did we hide our textures? We hid it under models, texture, here we go. Let's have a quick look. Shine damper, yeah, we started at 1, so we're looking at matte. Reflectivity of 0, there's no reflectivity at all on this one, it's 0. Reflectivity is the amount of light reflected. The higher the reflectivity, the more is reflected until you get to 1.0, where all light is reflected, i.e. a mirror. So that's a percentage from 0 to 1.0, whereas shine damper is in powers of 2, I usually go by, so 2, 4, 8, 16, 32. It's in powers as you are going to see, not just there, but also in the fragment shader. So let's put our last uniform in. It's a float again, isn't it? Yeah, and that's just going to be that reflectivity. Reflectivity. So yeah, we can have reflections. We can do reflections. So a static shader is for our static models. Now, when you want other things like water, I'd advise you to do something like a water shader. Don't use a static shader, whatever you do. Design your shader for the object that it's primarily supposed to be used for. This is primarily supposed to be used for a static object. We will be using it for moving objects, but that's irrelevant. That's because we can. It's a good enough shader to be able to handle that, but when it comes to animations later on, oh, that's a whole different ball game. A whole different ball game. So we need our void main. Let's get on with this. So I'm going to do lighting. Yes, we have not talked at all about lighting, really. Let's have a look at my notes then. If you think I can remember all of this, you're better than I am. Yeah, okay. So, my notes are telling me that we need to normalize everything. Now, you might not know what that means. So we're going to have a unit, which means 1, normal, and that is going to be normalize Z. Yeah, E. There you go, it comes up as a function that we can use, and we will do that to our vertex shader variable, surface normal. Yep. What that is going to do is it's going to take our surface normal and make its magnitude. Remember that all vectors have a position, an x, y, z, and a magnitude, a size. So its size will be whatever we pass in. Its magnitude will be whatever we pass in. We don't know what we're passing in, to be quite honest with you. We don't know whether it's already been normalized or not, whether it's a unit vector. Unit vectors are magnitude size 1. And there's a very big reason for it, because it makes all our calculations rather easy as soon as you turn it into a 1, a magnitude 1, because there's some special equations going on in here. And we need this. Let's have a unit light vector. Yeah, light vector. And we are going to normalize, believe it or not, our V underscore to light vector. Anyway, it's come up for me, that's nice. I like it when it helps me out, it's really good. Vec3. Unit. What am I going to call this one now? It's a vector. To camera. I've got to make sure I get this right, the right way round. If I don't, I'm going to mess everything up. Because it's from the object to the camera, not from the camera to the object. It's all got to be from the object. So light vector is to the from the object to the light, and the camera vector is from the object to the camera. It has to be that way round. It doesn't work otherwise. And we're going to normalise it. So you already know what I'm going to put in here, don't you? So it's to camera. Yay! We got that one right, I think. I think we're doing good here. Now we're going to need light. There are 3 types of light that we're going to be calculating. It's called the Phong, P-H-O-N-G. Oh, actually, no, I'll put this in for you. P-H-O-N-G, Phong lighting equations. These are a standard that taught at most universities or colleges. Phong lighting is a very simplistic way of doing lighting. It's the base lighting model that you should use. There are much more complicated ways of doing lighting, and they produce a lot better results, but I'll show you a trick with Phong lighting, and it took ages to get these equations right so I'd do it properly, so bear with me on it. There is ambient, which is your, so I'll call it ambient lighting, and this is your background light. Basically the light that's all the way around, oh god, the light that's all the way around you. That's better. Let's spell it all properly, shall we? Ambient lighting is the light that's all the way around you. It's the light that isn't produced by anything around you. It's a combination of all light sources. It gives a very low level lighting background to your area. Even though the corner of your room may be dark, it's still got light there. That's that background ambient lighting. And you might say you might walk into a room and say, oh, this has got nice ambience. Well, that's the background. It's got a good background feeling to it. The lighting is good. Or whatever. It can be mood lighting as well. So, you know, that's what you can use that for. Some people put it to 0 and don't have it. So they can do like horror and switch all the lights off and give you a black screen type of thing. It can be used in various ways, put it that way, to do various effects. So diffuse lighting. This is your direct light from each light source, so it has to be calculated for each light source. So this shader would have to be run for each light source, basically, from direct from light source. There we go. So that's how much light is being pumped out. That's going to be your light color. Basically, yeah, the light color will be doing that bit. And the last part is specular. Yeah, specular lighting, the reflections. They call it specular because it looks like specks of light popping out at you. I don't know how to describe it. It's quite strange. Specular lighting can be very wary about it. It's something you might sometimes want to switch off. It's that glint. That's the way of putting it. That glint off metal. When you shine a torch on a surface, it's that circular, round, sharp, direct light, rather than everything else that gets scattered off all the way around it. So you can, using specular lighting combined with the shine damper, you can make a spotlight very, very easily. And that is something to be aware of as well. So you can actually change your lighting standards using this. So you could have a spotlight, you could have a sun, you could have a desk lamp. You can have all three at once in the same room, and they would all mix together, and the diffuse lighting, the ambient lighting would all mix together, and you should be able to get a good effect. You know, it's one of those things, you just got to play around with the numbers sometimes. So that's how much you see reflected. I have to say that because if you are on the same size, if the sun is behind you and you are looking at water, you may see some reflections if there are waves reflecting the sunlight back. You'll get glints on the top of the wave. But if you are on the other side of that water, looking towards the sun, you will probably also get a large reflection of sunlight. So you'd have completely different type of reflection, and that's where the specular lighting comes into it, and why we need to know where this light is coming from compared to you, because the light vector will give the position to the sun, and the camera vector will give the position to you as the viewer. And that's how it works. That's how it all works. That's a better description of how it all works, I think. There we go. I've actually got a description that I agree with. Wow. It's a good one, that. Ambient lighting. How do we calculate it? Well, we're going to calculate it like this. We'll have ambient light. How about that? That's a good name for it. And how are we going to make it? I'm going to set it as a value. Simple as that. Yeah. I'm not going to pass it in. In later modifications, I would pass this in as a value so I can decide what the ambient lighting is going to be. And I'm about to choke. Okay, microphone switch back on, okay? Yeah, alright. Grab the coffee. So I'm not going to be passing this value in. You can pass it in as a uniform if you wish to, directly. I don't mind. But at this stage, to get up and running a very, very simple light model, I'm just going to make something up. So 0.1, I want low level lighting, so 0.1. And it's an F, it's a float. I don't want white, so amber colour is 0.05. I'm going to have it amber. Why not? It's called Amber SL after all. That will make that one about 0.025. It's a orange, an orangey, very, very dark orangey colour. Yeah, that'll do nicely. For the background, that's it. Done. Next. Yeah, simple as that. I'm not messing about with that one. Diffuse lighting will need intensity. A light intensity. So light intensity. May as well tell us what it is. Yeah. And this equals... You'll have to look this up. I'm not going to explain it to you, but it's the dot product of unit light vector. This is why we needed to normalize it, because it makes the dot product so much easier. And this will give us the correct answer only if you use unit vectors. Which one was I doing then? I've forgotten now. Oh, it's the normal. Come on, Blades. Get with it. I know you dim at times, but come on. Yes, unit light vector and the unit normal. If you dot them together, that will give you the light intensity as it looks from the light's direction. So there may be something in the way. Type of thing, like a wall in the way, and you're just getting a little bit of the light coming through or a part of the light coming through. So that will all be discovered in here. So that means that our Vec3 diffuse light, well, we'll call it diffuse light, why not, is going to equal our light intensity, and all we're going to do is multiply that by the colour. Yeah. Like that. Perfect. Magic. Done. Happy. Last one, specular. A bit more complicated because we've got these two vectors to reckon out. We've also got the specular and the damped factor to put in there. So we need to know the direction of the reflection. That's the first thing. So let's have reflected light direction. Yeah, I'm gonna put it all in as a variable. Why not? Name your variables properly at this point, because otherwise if you come back to them you'll have no idea what you've done, and neither will I. So there we go. Reflect is a function given by OpenGL. So OpenGL is going to do this for us. Your graphics card has this function already on it, like it has dot function already on it. So that's nice. So yeah, the graphics card is actually built to do this, so why not use it? It's going to be the negative, because I'll tell you why in a minute. Unit light vector. Light vector. And the unit normal. Yeah, that's right. So it's the angle. So what we're going to do is we're going to take the light. We are going to go, remember we've got that as to light, so it goes from the object to the light. So we have to take that as backwards. So we want from the light to the object, that's the minus unit light vector. That goes from the light to the object. The normal goes at 90 degrees up to the object. So if you reflect around the normal, which is 90 degrees straight up, the light reflected is the angle reflection. So that will just reflect it straight through the angle around the normal. Simple as. If you put the lines down on a piece of paper, if you put a surface down, say as this line, and where it says normalize, you put a line straight up for your normal, and you take your light source at the left corner coming down to the N, what we have is it going up to the light, so we have to put a minus sign in to make it come down. There's your normal, there's your angle, it reflects it around the normal, gives it that angle, and wallop, it reflects up off there, and it gives us the reflected light direction. There we go. It is that not too impossible to describe, but it's you're better seeing it graphically than you are trying to just work it out in your head. Put it that way. It works better for me in graphical form. So we're going to need a specular factor. This is going to come from a dot product again, and this is going to be the dot product of the reflected light direction. No, reflected light direction, and that's comma, and that is dotted with the unit vector to camera. There we go. That's lovely. That's your specular factor. How much that is gives us like the where. How can you put it? The angle between the reflection coming off the surface and the camera, where we are viewing the surface from. So that gives us that angle, roughly speaking. I'm only saying roughly speaking because you'd have to see it as a diagram. I really have to admit I can't explain it any better at this point. Right, the damped factor. I know what these things are, but I prefer to draw them for you. The damped factor is a power. Now remember I was saying it was 2468 at 1632. Well, this is where it comes in. We need to take the damping factor as a power. So like if it's something is 1 to the power of 10 would be 1 with 10 zeros after it. I'll give you an idea. Or no, it'd be 1 times 1 times 1 times 1 10 times, it'd be 1. I don't know, it's one of those things, I've forgotten now. It's a power. It's going to be something to the power of. Again, graphics card has the function for us, and we are going to use our specular factor, please. That's that one. And we are going to put that to the power of our shine damper. So that's where our damper comes in. Remember, this is to the power of, and you should have, for normality, a 1 is fine, because anything to the power of 1 is itself, so the specular factor would stay the same. The more you put, if you put that to the power of 2, then it's specular factor to the power of 2. Yeah, so it affects what we've done here with for the angle. It doesn't, well, it sort of increases the angle because you're going to get less drop off. It's the amount of drop off between the reflection and where you are looking at the object from. So it's the drop off factor. So that if that drop off needs to be lower and lower and lower to make it, so you can see the glint from a wider and wider angle, and it has to be to the power, because otherwise it just would never ever show up as working. I mean, I've tried it times 2, times 3, times 4. It just doesn't work to the power of. It works beautifully, and actually makes for a good equation as well. I think the original equations online are all to the power of as well for that damping factor. You can look it up. It's all there. Look up Phong lighting equations. Just Google C++ Phong lighting, or even better, GLSL Phong lighting equations. That might be better because this is GLSL we're writing it in. Why not? So, specular light, we finally got to it. It's going to be a VEC 3. Oh, I've already put that in, sorry. Specular. And light, we've actually got the final thing, is going to be your damped factor. And we're just going to multiply that by the reflectivity, how much reflection there is. So reflectivity, please, that one. And we're going to also multiply that by U underscore light color, please. That's it. That's all we need at that point. And from those 3 items, we need to calculate now the final lighting. There we go, let's do that. And it's going to be a VEC 4. It's going to be called lighting. And it's going to equal a VEC 4. Yeah, I know, it's pretty simple stuff, but hey ho. So, what is it gonna look like? Let's have a look at my notes. Right, we're going to have to clamp them, because lighting, the final lighting calculation can only be between 0 and 1. Lighting has to be a percentage, and it has to be a very specific percentage. Alright, let's have a look. Okay. Okay, I'm trying not to confuse myself now. Okay, we just need to place in one value. Okay, this doesn't read right to me. No, I don't know what the line is. My apologies. I'm just going to check on the original shaders that were written. StaticShader.fs. Yeah, it is what I'm thinking. Yeah. Okay. Fair enough. That's alright, as long as it's what I'm thinking. It's horrible. It's a horrible one to write. It's not something I can memorize either. So, it's clamp. We need to clamp it between 0 and 1, otherwise we're going to be in big trouble. So, clamp. And it's Vec4 clamp, specular light. Specular light, and we want that from 0 to 1 as the minimum and maximum value that it can be. We don't want any negative numbers, and we don't want any number above 1. That's its maximum. Plus separate line because it's easier. We're going to then clamp. And this is going to be the diffuse light. And again, 0 to 1. And we also have to add, so all it is each one added. So specular, diffuse, and then ambient. Okay, it doesn't matter which order you do this in, because it's plus. That's all I think. I'm not going to put clamping on this one. Actually, shall we? No. Ambient doesn't matter. Ambient. And then we want a comma. Sorry, it's ambient light, isn't it? Sorry. See? I can still mess it up even though I've just looked at it. And at the end we'll just have 1.0 float. Yeah, that'll do it. Because it's a Vec4. So it's going to put in our specular light plus diffuse light plus ambient light, all of which are Vec3s, and to turn it into a Vec4 we have to put the 1.0 at the end, and that's it. Yeah, that'll work. That is fantastic, so that adds up all of our light. So our light at this point could actually be 2 point or 3 or whatever. Yeah, it could actually be anything up to about 3. Wow, I didn't realise that. Interesting. Well, it can only accept up to 1. I don't know what it's going to do with 3. Not much, I hope. No, it doesn't matter. It just counts it as 1. It'll do its own little clamping. It matters for the plussing part. They've all got to be within the same ranges. So, yeah, for completeness, just for everybody, we'll do the ambient. 0.0f, comma, 1.0f, close brackets, comma 1. There we go. Yep. I'm going to put clamping. The reason I didn't have clamping before is because I already know what it is. It's static. But you might change that. And if you do change that, you won't realise that you need to clamp it as well. So there we go. I'm just putting that in for safety. It doesn't have to be clamped, that part, but hey ho. It doesn't matter if we do. So, we've got to the last bit. The final fragment colour. Remember, it's not a pixel yet. I'm going to call it out because it is. We called it out, didn't we? We're going to be sending that out. The final fragment out colour, which is that one there, that gets passed out and gets rasterized and placed onto your TV if it's valid. If it's not, it gets discarded. There we go. Sorry, if it's valid, it becomes a pixel and goes onto the TV. If it's not valid, it gets discarded. That's how it works, literally. In other words, if something is blocking it, another object is in front of it, then it can't be seen, so it gets discarded. It doesn't draw it. So, normally, I would go GL, frag colour. Yeah, we can't. Well, we can, but I wouldn't advise it because I've checked. I've checked and I've checked and I've checked. And it would seem that it's depreciated. It no longer exists. So I'm going to put colour in now. And I'm going to put lighting. If we get errors off this, I'll be amused. Because I've just looked it up today to make sure that I'm right. Literally, before sitting down to make this, I was on Google looking up GLSL, GL_frag colour, and reading up what it said, and it said depreciated next to it, so we're not using it if we can. So that's the texture we need. And if I remember right, that was _texture. I think you'll remember this from the base shader. Comma V_texture text coord. There we go. Again, we discussed it before, didn't we? Texture, UTexture, VText undercode goes into the text color. Well, the text color is no longer color doesn't equal text color because now we have lighting included, so it's lighting times the texture, and that will light our texture up. Isn't that nice? Isn't that nice and simple? I'm hoping it makes sense, or some of it makes sense. If it doesn't, don't worry, forget about it and just carry on. I don't mind if you don't quite understand what's going on here. Don't worry about it. If you want to learn how to write shaders, take a shader foundation course or something like that, and that usually covers Phong shading and how it works, and we'll have all the diagrams and pretty explanations, a lot better than I can do. I'm not a teacher. I'm not a professional teacher. I'm also not the brightest penny that you've ever met, so it's just one of those things. I understand how it all works, and I could probably show you all the diagrams, but I've got nothing to draw with, and I've got no tablet with a pen that I can plug in to draw with. This is another reason why I need Patreons, because if I had that kind of thing, I'd do it. It's as simple as that. But that's your fragment shader. It's all done. We're at 39 minutes again. I've just thrown a ton of information at you. I've said Google a lot of it, but I'm not a teacher. Sorry, apologies. This code is correct. It is functional and it works. And it is wonderful. There's a little speciality, a little tweak that I've put in there that you might not find if you go and take the course. You might find it, but you might not. Anyway, you'll see what I mean when you come to see the end results. It's spectacular. It really is spectacular. So, I'm going to say a goodbye for now, and in the next episode we're going to go on to terrain shaders. Yeah, we're going to actually write separate shaders for the terrain. Why are we going to do that? Simply because terrain will... you might want it to reflect and deal with light slightly differently. You also might want your terrain have adjustments, and you don't want, if you adjust the terrain, you don't want to adjust the models. If you've got something in your files that are set up differently for terrain and models, you'll want to be able to do a different shader. Trust me, I'll show you as we go through. I think it's going to be virtually the same as this one, to be quite honest with you, but we'll see. So I will catch you in the next episode of Blades Forgets All, and we'll have a good time with it, and we'll have a bit of fun. So you lot take care till then, and have fun.